This is video 5 for the higher paper 3 exam. The first topic we've got here is all to do with interquartile range, so lower and upper quartile, and then this will lead on to box plots in a moment. First thing it's asking us to do is to find the lower and the upper quartile from a list of data. Now the first thing you'd need to do is to put the data in order. Thankfully this has already been done for us on this question. In order to then find the lower and upper quartile, which in other words are the 1/4 of the way through the data and 3/4 of the way through the data, first thing we would need to do is to find the median. So the median is simply the number in the middle of the data, so just counting in, we would get that the median here is 0.40, I'm just going to label it up with median. In order to find the lower quartile, we need to find the value in the middle of everything that's smaller than the median. So here, the 0.37 is in the middle of all of this on the left, or the smaller numbers, so we would say that the lower quartile is 0.37. For the upper quartile, we do the exact same, but for numbers that are bigger than the median. So everything that's bigger than the median, the middle number here, so this 0.45, so we just say that the upper quartile is 0.45. Now it's quite likely that you're going to be asked then to use information like this on a on a box plot. In order to draw a box plot, we need 5 pieces of information. We need the minimum, the maximum, so the smallest and largest values. We need the lower and upper quartile, we've just found that. And we also need the median, again we've just done this on the last page. So if we were drawing this information, we are going to plot the 5 relevant values. So if we just bring this sheet back in, the minimum is 0.27, so I just plot a point at 0.27, so that'd be here. Lower quartile is 0.37, so again plot a little point, we'll join these up in a moment. Median is 0.4, so I just put a little dot at 0.4 for now. Upper quartile was 0.45, and then the maximum value is 0.54, so that gives us a dot there. In order to then draw the box plot, all we do, preferably using pencil and ruler, which I'm sure you'll do in the exam, is the 3 dots in the middle. They form the box, and then we've got some little whiskers coming off on either side, going out to the minimum value and the maximum value. So this is what our box plot would look like. You then might be asked to compare 2 box plots. For the maths exam, all you need to be able to do is to compare 2 values. That's the median and the IQR, the interquartile range. So for the median, we simply need to look for the line in the centre to see which is bigger. So this median is bigger than the second one. So we've got the first batch, or first sample, has bigger median. In terms of the IQR, we're just comparing the size of the box. So here, IQR is bigger for the second sample. And we need to put one of these facts in context. So because we've written IQR second, we'll use that one. Therefore, results more varied, because that's what an IQR measures. The bigger the IQR, the more varied the results. The next question is a bit of a ratio problem. So here we've got values A, B and C are positive integers. So in other words, positive values that are whole numbers. We've got the A to B, or A and B, whatever they represent, are in the ratio of 4 to 7. And then B and C, whatever they are in the ratio of 6 to 11. What it wants us to do is to find out the smallest value of A, B and C. So in other words, we are going to try and compare two ratios. Now what you might notice is that both of these ratios have a letter in common. That's the letter B. In order for me to compare this ratio with this ratio, what I need to do is try and make the value for B in both of these the exact same number. At the moment it's not. This one is 7, this one's 6. So the first thing I would do is try and work out the lowest common multiple of 7, because that's the one that represents B here, and 6, because that's the value that represents B in this ratio. Well, the smallest number that's in both the 7 and the 6 times table is 42. So what I'm going to do, just rewriting this ratio on the left, is I need to try and make this value, the 7, into 42. I've done that. I'll look at this and think, what do I need to do to 7 to make it into 42? I've times it by 6. So I have to do the same to this, otherwise I'm changing the ratio. So A is 24. Same with this ratio over here. I rewrite the ratio. And this time we want to change this value, so the one that relates to B, into 42. Well, what do I do to 6 to make it into 42? I've times by 7, a little bit of a link here with these numbers. So if I've times that side by 7, I must do the same to this one to give me 77. Just be very careful, it will not always work like this. If the lowest common multiple is not just the two numbers multiplied together, you don't just times by the opposite number. So just look out for that if that comes up in the exam or future questions. What we've now got, that the smallest values of A, B and C, where we can use as a comparison, are these. So A is 24, B is 42, because it's the same in both, and C is 77. So, because the question said add these three together, what's the smallest value when we add them together, we would just add these three to find out the smallest value. We get 7, 9, 13, 7, 11, 13, 14. The smallest value we've got here is 143. The next question is all to do with permutations or combinations. So what we're looking at is how many different values or how many different numbers follow certain criteria. So here's a particular question. It says that Jack has picked a 3-digit odd number. It tells us that the first digit is bigger than 7. So let's start. The first digit, if it's bigger than 7, that means it can either be 8 or 9. So there are two possible numbers that the first digit could be. The second digit, it says, is less than 6. So the possible values it could be are 0, 1, 2, 3, 4 or 5. So altogether there are 6 values that the second digit could be. Now it hasn't explicitly told us anywhere here what the third value, the third digit, could be. However, if we look back at the top of the question, it has said that this 3-digit number, whatever it may be, is odd. Odd numbers, remember, end in either 1, 3, 5, 7 or 9. Obviously even numbers 0, 2, 4, 6, 8. So here there are 5 different numbers it could be. Now here's the little trick that you can use. Because I know there's 2 possible values that the first one could be, 6 for the second, and 5 for the third, instead of me having to list out every possible number that I could have, what we can do instead is simply multiply how many different numbers each one could be. So if we do 2 times 6 to give us 12, times by 5 gives us 60. So that means there are 60 different numbers that he could pick. In other words, 60 different combinations that follow these criteria.